kind of forget that when it just keep talking and I forget what the hell's going on. If you missed a quiz and you did not tell me you were going to miss it or something, I mean, we need to talk about that. So you got to send me some kind of a communication. I mean, in general, you're going to miss class, send me a message. You're going to miss a quiz, definitely send me a freaking message, right? I mean, that's kind of big. It's addressed on the syllabus. So yeah, if you have some missing grades and you think it's messing up with your overall average, just communicate with me. It's amazing. And just respond. Somebody sent me a message about that. So I'm just talking about that. Anything else, guys? Anything else from quiz, homework, grades? If anybody just joined the class, put up in Canvas at the very bottom of your grades, there's 3 new grades in there. You want to take a look. All right. Okay. I wanted to give some time this morning for questions from homework, but if nobody has questions from homework, we're going to go right back into it.
I have one from the quiz, maybe.
All right, sure.
On this first one, I can't see what the problem was.
But I need to unlock that. Hold on.
I think I ended up answering y minus y1 equals mx minus x1, but I lost 6 points because I don't think I defined m.
Yeah.
How do I do that?
Well, what's the formula for slope?
X1, x2 versus x1, or x1 versus x2?
And that'll be on the bottom. So it's always rise over run. And what rhymes with rise? Y's. So y's are on the top, y2 minus y1 over x2 minus x1.
Oh. Okay.
So rise over run, y's over the other guys.
Yeah.
I like it. So that's kind of integral. That's why you lost a decent chunk of points on that one, because that's a huge step, is to figure out the slope. Otherwise, it's going to throw your graph off. Yeah.
Okay.
Anything else, guys? From the quiz, can you guys, can somebody go in there? So Ian, are you not able to see your which quiz you took? If you go in and take a look, you can't see it. I thought I had it set up so you could still see it.
Tab over and unmute. I can hit quiz 7. Submission and rubric. Click here to download a copy. Yeah, I can see it. I was just looking at my quiz itself. Okay,
good. I try to have it set up so that makes it easier to do corrections, obviously, if you can see your quiz. So, okay. All right, so let's get back into where we were last time. Let's see. Whoa. Okay, computer, calm down. Let's see, where am I? Oh yeah, I'm in 4.3 right now. So let's see, yeah. So the last, we did the ducks thing. This is about quadratic equations. So of course I'm wearing my basketball shirt. When I play basketball, I'm not calculating equations in my head, thank God. We just sort of do it, muscle memory. All right, so this is this business here. That's the quadratic equation stuff. What we're about to get into, oh yeah, and then of course we did get into 4.8. This is where we did the revenue, the cost, the profit stuff, and really the whole purpose behind that is that's an excellent real life application of algebraic manipulation, right? Manipulating algebraic expressions. Holy shit, Jeff, talk English. Adding, subtracting like terms. So that's without, and of course, multiplying binomials in this case, multiplying algebraic expressions. And that's where we have the FOIL method that I hate. Okay. Blah, 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 blah. Let me see. Is there anything here I left off? I don't think so. Yeah, let's do a couple of, let's do 1 and 2 real quick here, guys. Can you guys, I say let's, and I mean you. You guys do number 1 and 2. And I'm going to go get some drink. Drink. Man, my refrigerator is bare. I need to get to the grocery store. Number 1 should be very easy. Number 2, there's something to be very, very careful about with number 2. What happens on number 1? Does anyone have that yet? Does anyone have number 1 yet?
So the 5x to the what power? Is it to the second or the fourth? I forgot.
What do you have 5 of? What do you see 3 of here?
X's.
X squares. And what do you see 2 of here?
X squared.
X squares. So what do you have 5 of? X squares. So the power can only change when you multiply, because what are powers based on? What are exponents? Sorry, go ahead.
Multiplication.
Multiplication. So they can only change when you multiply. That's almost too nice to believe. Does that make any sense?
Yes.
So here I'm adding, so the exponents will never change, because why would they change when you're using an operation they're not based on? So this is just consolidation. 3 of these plus 2 of these is 5 of these. Right? So if you do put 5x to the 4th, I'll go, holy shit, I don't see any x to the 4th. How do you get 5 of them? I'll be a real dork, like, you know, just who I am. I'll just be me. And then, of course, what happens with the 3x?
Cancels out.
Cancels out, so there's no x term. And then you got 5 minus 10.
So minus 5.
Done. So everybody cool with that? Now, does somebody else know what on number 2 would throw people off? How is number 2 different?
Because it's minus and not plus.
Yeah, this little dude right there. This was easier because it's a plus. So that doesn't change any of this. Plus this, plus negative 3x is still negative 3x. But what happens with this negative? What do I have to do with this negative right here?
Distribute it.
All right. So hopefully everybody else is quiet, because this should be relatively simple. We've done this kind of thing before. So distribute the negative, negative x squared, negative 2x is plus 2x. Negative 7 is negative 7. That's crazy. And now it's the same thing. So what I do, I don't know if you guys notice, I like to kind of like underline my like terms with similar underlinings instead of moving shit around, or you don't have to do that at all, you know, whatever floats your boat. So then I get 4x squared plus 5x minus 5. Okay. All right, so that needs to be semi-old news. Okay, so what about number 3? What's the only thing you got to be careful about with number 3?
You need to distribute the 3 and the 2.
Yeah. So it's really the same thing as this, the negative up here, because that's sort of like a -1 in front of it. So whenever you have a number that's not 1 in front, you have to distribute that first. And then you can just put your like terms together. So it's really the same problem. I just have that first step to do. Okay. How's everybody? Is anybody having issues with this? Okay, we've done this kind of stuff before. This is awesome. We're getting to the freaky stuff in a minute. So to do this one real quick, I would just triple everything inside here. And then I would double everything inside here. And then I could just put together. So that would be 5x squared plus 9x minus 6x, so plus 3x plus 15 minus 20. Man, they got to think about -5. What the hell? -5, -5, -5, crazy. All right, nothing major there. Nothing major there. Ooh. So I'm going to clear this away. Here it goes. Go. Same thing here. Who cares? All right. And let's do this real quick. Do these two real quick, 5a and b. All right, so this is, of course, that FOIL thing that I there's no reason to say FOIL, but oh well, too bad for us. I distribute the y, and then I distribute the -5. Oh, go ahead.
Yes, y power 2 minus 7y minus 7y
Plus 7y,
or plus 7y. Sorry.
because it's y times +7. Now you do -5 times y, and -5 times 7,
35.
-35. I like it. Okay. And then, of course, what can you do? What's 7y minus 5y?
2y.
So yeah, I get here. Bam. All right, now let me do some extra shit with this. Here we go. Here's some extra shit. This is not to do with the problem. This is just Jeff doing some extra shit, getting us ready for weirdness. Let me clear some of this, all my scribble scrabble up here. Tell me real quick, somebody. What do you get here if I make y equal to 6? What does this become? So what's this here if y is 6? What's this first piece?
6 minus
1. And what's this piece?
13.
So I get 13. That's amazing. And if I make y equal 6 in this guy, I get 6 squared is 36. 2 times 6 is 12 minus 35. 36 minus 35 is 1 plus 12 is 13. Same answer. So that's old news. That's like, who gives a shit, Jeff? So on the one hand, it's kind of neat. And on the other hand, it's like, well, of course, because these are the same. These two things we just proved, they are the same. So of course they come out the same, Jeff. Get over yourself. Now, let me ask you this question. Can somebody pick a number to put in for y that would make the answer 0?
Five.
5. Yeah, if I make y equal to 5, right off the bat, what's the first piece?
Zero.
Make y 0. Yeah, 5 minus 5 is 0. Times who gives a shit, right? It doesn't matter what the second dude is. He happens to be 12. Who cares? Because the first dude was 0, the whole thing is 0. Are you with me? And I really want this understood. Why would I care so much about what makes this kind of thing 0? Because so many profit functions look like this, right? Whenever I draw this, I think the Legion of Doom. I don't know if you guys remember the old, anyway, sorry. That's a side note. It has nothing to do with this. Go away. What are these points again if this is a profit function? What are these points?
Break even.
Break even points. So almost always, in fact, basically always, these x-intercepts mean something important. So I want to know, is there a way to figure out what are called the zeros or the roots? Right? Those are two other words we use for x-intercept. They're called roots because it looks like the ground where roots start on plants. They're called zeros because they're the thing that make the whole thing become 0. Is everybody with me so far? Have you guys heard these words before? Zeros and roots in math context, right? No? Okay. So does it make some kind of sense? To call them zeros makes sense because, so for example, this is a 0 of this because if I use it, it makes the answer 0. It's also called a root, which is the weirder word to use, but it's just because if you look at this like the ground, isn't this where the roots would start? That's really, really, you're like, really? Old math people? Really? Really? I'm like, yeah, they did. They did. So we call them roots. Give me a break. Okay. What else would make, I'm gonna erase all this stuff right here. I'm gonna erase it all. Here it goes. What else makes this thing, not all this, just this, the red stuff. What else makes this thing 0?
-7.
Yes. So do you see how, all right, is everybody cool with, anybody not cool with the fact that this is this? They are the same thing. They just are written differently. Sort of like me saying 7, 5 plus 2. They're the same damn thing, right? They're just written in different ways. So this is before I multiply and this is after I multiply. Which form can I see the zeros? This one, obviously. So what's 1 0? Y equals 5 because it makes this guy 0. What's the other 0? Like Vu said, y equals -7. Does everybody see that? Wouldn't that make this piece go to 0? -7 plus 7? Maybe, maybe. All right, I'm getting a little bit ahead, but we're about to get deep into what I'm talking about right now, which is doing this backwards. We're going to get to a point where we're able to do this backwards. We're able to have this and break it up. And I know you're all like, go ahead, sorry.
How about factoring it out?
Factoring, exactly. I love it. All right. Let's see. And this, of course, we could do all the same thing we just talked about here. It's a little bit harder. Can somebody figure out what a zero of this one is? How would you figure that out? So again, what makes a number a zero of an expression? If I use it, it makes the whole thing become zero. That's what it is.
-3.
Yes. Sorry. Why am I so excited? Who knows? -3. -3 is a zero because if I plug it in here, and of course here, who gives a shit about this? Because when I plug it in here, I get twice -3, -6 plus 6 is 0. So does everybody see why it doesn't matter what this thing is? Once you get it 1, 0, the whole damn thing is 0. What makes this piece 0? You can't guess that one, can you? So watch what I can do. Watch what I can do. What am I trying to figure out right now? I'm trying to figure out when is 3x minus 8? When is that equal to 0? Holy shit, that's an equation. I can solve it. I write down in Mathish the English question. I'm trying to figure out when is 3x minus 8 equal to 0? All right, solve that. So 8/3. That's why it was difficult to figure out in your head, because it's a gross fraction, right? So if I put 8/3 into this, it will become 0. Okay, how are we doing out there? So I went a little bit further than the question because we're about to get into the stuff I'm talking about. All right, so I'm going to clear all this away. Here it goes. Blah, 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 blah. Yeah, and we remember we did these. Do you guys remember that? And I did the special one where a lot of stuff canceled. I don't know if that sounds familiar to anybody. Go ahead and do this maybe. Screw all this shit. We don't need all that shit. Just multiply these two together. You understand? Screw A, B, and C. We don't need it broken down that much. We're better than that. So let me make this really clear. Screw you, A. Screw you, B. Screw you, C. We are better than that. We can just multiply this shit. Let me put it over here. We don't need this much help because we're not FOIL idiots. We know this is just distribution. Ooh. Ooh. So when I do x times x squared, what do I get?
Power 3.
Yes, x cubed. And then the second thing I do is x times 3x. So I'm just distributing the x. That's all I'm doing. X times 3x.
Power 2.
3x squared. I like it. And then x times 4. Just 4x. That's crazy. And then -5 gets a turn. So that just becomes -5x squared. Let me line these up. -15x. And then -20. Sheep. Do you have to do it this way? No. But I just like to do it this way. X cubed minus 2x squared minus 11x minus 20. Shapow. Can somebody tell me a 0 of this? What value of x makes the output 0?
Five.
Yes. If I make x 5, then this first little dude is 0. Now here's something that'll blow your mind. This one has no zeros. There is no value, no real, let me say it like this, no real zeros. There's no real number you can put in there and make it come out to be 0. Is anybody freaked out by that? No? Okay. All right. So we're kind of caught up to where we left off, I believe. I'm going to clear all this away. Pow. Blah, 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 blah. And then the homework here, of course, they're going to have profit and cost and revenue problems to work with, right? Shouldn't be too horrible, hopefully. And I think they have, nope, they don't. How about that? All right, they don't have any straight up algebra problems. Oh, well. Let's see. Now, we are stepping into what I was just saying a minute ago, and what Vu confirmed was factoring, right? The F word. So normally in the list of what students hate the most in algebra, it's normally word problems is king, of course. And then graphing is normally second. Of course, each individual might be different. And then third is factoring. I kind of understand that. So let's see now. Yeah, this is silly. Let me ask you this. Let me do something. You ready? This is going to be related to what we need to do. Now just look at this as a puzzle. Can you come up with 2 numbers that add to be 9 and multiply to be 20? Don't say anything if you come up with it. Just hang on. Does everybody understand? This is just a puzzle. This is just me asking you a little kind of computation problem. I want 2 numbers. They have to add to be 9, and they have to multiply to be 20. Oh, I'm getting some chats. Let's see. I like it. Good. Everybody chatting to me is right so far. Somebody else think they have the answer? What's the answer? Anybody? Do you guys?
Ryan, 5 times 4 on the chat.
Oh, did he give it? I thought he just directly messaged to me.
No.
Ryan, geez, all right. I love you guys so much. 5 and 4. Do you guys understand now? If you didn't really quite understand what I meant with this problem, 5 and 4 do both things. They add to be 9 and they multiply to be 20. How did somebody figure that out? Did it just come to you, or did you have to work it out a little bit? Can somebody tell me what they were doing? What kind of work were you doing? You're like, my work was to sit here and wait until somebody came up with the answer, Jeff. No, not acceptable. One way to do this is to list all the numbers. So 1 times 20 is 20, but they don't add to be 9. 2 times 10 is 20, but they don't add to be 9. You guys with me? 4 times 5 is, holy shit, they add to be 9. Yay. Or the other way to do it is to say 1 plus 8 is 9. They don't multiply to be 20. 2 plus 7 is 9. They don't multiply to be 20, but I'm getting closer. Do you guys see that was 8? And this is 14 when I multiply them together. 3 plus 6, but that's 18, right? If I multiply them, and then 4, 5, yes, 20. Yay. So there's kind of 2 ways, but both ways are the same. Make one thing work and then check to see if the other thing works. Is everybody semi with me? You need both things to work at the same time. So this is one place in math where guess and check is allowed. All right, let me clear this away. Let's do one more of these. And this time, privately chat me if you get the answer. All right, so I want 2 numbers that add to be, oh yeah, let's do this. Add to be 1 and multiply to be, what do you got, Jeff? Negative 72. Ooh, gross. So again, don't chat to everybody. Don't say it out loud. You can privately chat me if you get the answer. And you see how this could have been something I did on the first day of class? This is just playing with numbers. That's all this really is. And this does have a purpose. I really want you guys to understand. This isn't Jeff suddenly going insane and saying, let's just play with numbers. This has a purpose. This is something we're going to do in this section. This one's freaky one, isn't it? Can you guys tell me, since they multiply to be negative 72, what must be true about the 2 numbers?
1 is negative.
Yes, 1 is negative, 1's positive. So if they add to be 1 and they're opposite signs, that actually means that they are 1 apart. Let me erase some of what I just did. Good, sorry. So if you start thinking, well, what multiplies be 72? 2 times 36, but that doesn't make 1 if I make 2 negative or 36 negative. Nope. Right? Or 3 times 24, is that right? Yes. But that doesn't make 1, obviously, either way I do it. Nope. That would take a while. I'd rather do this. You ready? What 2 numbers are 1 apart? 4 and 5. And if 4 is negative, that would multiply to be negative 20. I'm not there. It's too small. So let me make my numbers bigger. What about 6 and 7? Are you guys with me at all? It doesn't matter which thing you make work first. So I can either list factors of 72 until I go insane and try to add them to be 1, or I could just list things that add to be 1. Don't negative 6 and 7 add to be 1? But what's negative 6 times 7? Just 42. But I'm getting closer, aren't I? Okay, I'm going in the right direction. So maybe 8 and 9. They add to be 1, don't they? Negative 8 and 9. And what's negative 8 times 9?
The answer.
The answer. Holy shit. So the 2 numbers are negative 8 and 9. So to
Just
me,
basically climbing there, huh, Jeff?
Say again.
That's like a Klein technique right there.
Yes, yes. I call it a Price is Right technique. Higher, higher, you know, lower, higher, lower. So you can kind of narrow in on the right answer after you've written a couple of guesses. There are multiple ways to do this. And if you came up with a different way than I did and it works, beautiful. I love it. Share it with me. Maybe I'll steal it. Maybe I'll name it after you. I'll teach future students and I'll say, this is the Linnell process, right? All right, let me clear this out the way. Clear. Okay. So let's do a couple of these things. I don't like all this shit. Blah, 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 whatever. Blah, 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 blah. Yeah, this is interesting. We just did this stuff here. Look at number 9 real quick. Do number 9 very quickly. This should be really quick. They give you an expression and they ask you to evaluate it when X is these things. Go ahead and do that kind of quickly for me. Quick. All right, so let's take a look here. This should be relatively quick, right? I mean, if you put a 2 in here, -2 times 7, you get -14. Is that cool? When you put a 4 in, you get 0 times who cares? You get 0. When you put a 0 in, you get -4 times 5, you get -20. You put a -1 in, you get -5 times no, Jeff. There you go, buddy. Get -20 again. That's interesting. And when you put a -5 in, you get -9 times 0, you get 0. So now watch this. This is nothing they ask you to do, but I'm just going to do this real quick. Maybe don't even try to write this down. So when X is 2, the output was -14. Don't try to copy this down. Just watch. So when X is 2, the output's -14. When X is 4, the output was 0. When X is 0, the output was -20. Oh, shit. 18, 20, okay. When X is -1, the output's -20. And when X was -5, the output was 0. So can you see how this is tracing out a parabola? Parabola, if you want to say it correctly. You guys semi with me? We already knew this, right? We know that x squared stuff looks like a parabola. So why isn't this one sitting here? Because it's got all this extra shit that kind of moves it around. Well, let me stop for a minute. What are the zeros? We just figured out what the zeros are, didn't we? What are the zeros of this thing? What are the values that make the output 0? That's all that means. When did I get a 0 output? When x was what?
4 and -5.
4, -5. What's happening on the graph for those inputs?
They're on the x-axis.
Good, they're x-intercepts. Cool. All right. So since when I put them in, the output is 0, meaning it doesn't go up or down, it's on the x-axis. So these are, it's just another name for x-intercepts. Maybe. All right. Let me clear all this away. All right, here it goes. Bye. Blah, blah, blah. Let me see, is anything useful here? No. All right. Is this useful? Sort of. All right, here. Wait. Let me get to the, here we go. Now watch. So they've already done this graph for us, right? Here's all the values they used. A and B are the same question. Do you guys see that? Because 0 is just another name for x-intercept. So once you do A, you got B. So can you guys see the zeros, the x-intercepts? What are the zeros and the x-intercepts? You could either look at it, where does it make the output 0, or you can actually look at it and see where does it hit the x-axis. Either way. So what's this?
It's -3 and 1.
Yeah, -3 makes it 0, and 1 makes it 0. So let me show you. Remember, the problem we just had was this guy, right? Isn't this the problem we just did? And weren't the zeros for this -5 and 4? And you can see that on the graph, -5 and 4, the graph I just made, right? Let me stop for a minute. I really want to make this connection really clear. I know how to factor this now. I know exactly what this x squared plus 2x minus 3. I know how it factors. I know it. Since x equal -3 is a 0, what must be here? Just like, wasn't -5 a 0? And what's in there? Why is -5 a 0? Because there's an x plus 5. I really want you guys, do you guys see that? I'm just going to look at this backwards now. I could tell that -5 makes this piece 0 because it's adding 5, and -5 plus 5 is 0. But now I know -3 makes it 0. Therefore, what must be here? X,
3.
say again?
+3.
Plus 3 must be there. And x equals 1 makes it 0. So what must be here? Just like 4 made this thing 0, and there was an x minus 4. 1 makes this thing 0, so there's an x
-1.
minus 1. Now, real quick, watch. If I multiply this out, what do I get? X squared minus x plus 3x minus 3. Isn't that x squared plus 2x minus 3, which is the same thing? Now, that is not a very effective way to factor things because I don't always have the graph to look at. But that's making a connection. If I have a quadratic that factors, then it must hit the x-axis at the roots, at the things that make this 0. So does everything factor? How do I answer that? Yeah, but does everything factor nicely? No. Right? This one factors nicely. I mean, these are beautiful numbers, 3 and -1. I could have something that factors with 3 plus square root of 5 over 7. Is that nice? No, that is gross. Right? All right, let me clear all this away. So the point that, before I clear this away, the point that's trying to be made, the point I made earlier is these are important points, and so is the vertex, of course, but right now we're going to focus on these. Where the output is 0 is important. So if I could factor something, I can just look at it and tell where it's 0. And if they are very important points, I would like to know how to factor something so I can just look at it and tell. The same way you guys looked at this thing up here and you could just tell me what the zeros were. You could just tell me. When it looks like this, I can't do that. I can't just look at that and tell. All right, let me clear this away. Okay, here it goes. Blah, 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 blah. Ooh, yeah, this is nice. What are the zeros for number 5? So again, zeros just means what values of x make the output 0. So what would make this 0?
-5.
-5. And I really want you to understand, I only have to worry about one thing at a time, because if one piece is 0, it doesn't matter what the other pieces are. 0 times I don't care is 0. What makes this one 0?
-4.
And what makes this one 0?
2.
2. There you go. Those are the zeros. Now, if I multiply this out, it would be x cubed, blah, blah, all this other shit, and I wouldn't be able to see this so easy. So that's good motivation as to we want to have a way to break something up into its parts. These are the parts of the whole thing. I want to be able to break it up like that, because then I could just look at it and see what the zeros are. Okay. So here's a couple things. All right. All right, let me see if they do enough of this. Not really. Okay, so I'll do this one and then I'll do some more with you. Take a real quick minute and just multiply this out. They tell you do not combine like terms, but I'll come in there. We'll do it. I'm just going to do a bunch of these. All right, here we go. You're going to love this shit. So I'll let you do this one, and then I'll do several more very quickly. Please, you gotta let me know. Come to office hours or something if you have any trouble doing this step here. This needs to be relatively easy. So it looks like I get x squared plus 12x, and then the 2 gets a turn, plus 2x, and then 2 times 12, 24. So I'm going to go one step further than they said. I'm going to add those together. So somebody tell me, what piece of this problem, where did 24 come from? What can you point to in this problem that 24 came from it? Where did 24 come from?
2 times 12.
2 times 12. When I multiply two numbers, I get 24. Where the hell did 14 come from? From the original problem.
From the original problem,
Yep.
where you ended up the addition from the 12 and the 2.
Yeah. Same two numbers. Add to be 14. Multiply to be 24. Doesn't that sound like that thing we were doing earlier? Right? Well, let's try this again. Maybe it's just special for this little thing, Jeff. Maybe it doesn't work all the damn time.
Oh, wow.
Here we go. I like that. Good. I like that reaction. So what if I have x minus 7, x plus 4? Let's try this one. So if I do this real quick, I got x squared plus 4x minus 7x minus 28. So I get x squared minus 3x minus 28. Where did negative 28 come from? Negative 7 times 4, right? Where did negative 3 come from? Negative 7 plus 4. What the shit? Now, of course, some of you guys hopefully are like, well, of course it did, Jeff. That's how FOIL works, Mr. FOIL hater. Sorry. All right, that's true. It is, but it's still a little nifty. So now watch this. All right. Yeah, blah, 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 blah. Watch this. Everybody watch me. Watch. So if I had x squared, what do you got, Jeff? Plus 7x plus 12. And I want to know, how do I break that up? How do I do what we just did up here backwards? How do I take this and say, where did it come from? What two things did I multiply to get this? Well, I need two numbers that multiply to 12, right? Isn't that what the last term always comes from? It comes from these two numbers multiplying. And I need two numbers that, and the same two numbers have to add to be 7. And really, what has to go, now stay with me. We're going to do more with this, obviously, but what has to go here and here to make x squared show up in the beginning? What has to go here and here to make x squared? Yeah, x and x. See, that part I know. That part is known to me. I know it's x and x. It's the last part that I need to do this little puzzle thing over here. Because it could be any two numbers but they have to be multiply by 12, and they have to add to 7, or else there's no way it would be the same thing as that. So what two numbers multiply to be 12 and add to be 7?
4 and 3.
Yeah. So that's how you factor the damn thing. That's how you tear it apart. You're tearing me apart. I mean, I really want you guys to see people kind of make factoring at the same time that it's really fascinating. It's also really mundane. It's like, well, of course that's how it works, because that's what always happens when you do this shit. The last number is the multiplication and the middle number is the addition. Ooh. So on one level, it's like, holy shit. And on the other level, it's like, well, of course that's how it happens. Of course it is. So again, just to remind you guys, whenever you do, go ahead. Sorry.
My bad. I was gonna say I'm still on the ooh part, not the.
No, you're good. No, that's not a bad place to be. I like the ooh part much better than I like the part. Right? All right. So let me show you another thing that we've done before, but now it's even more meaningful. Somebody pick a value for x for me. Anybody? What do you want to make x equal?
9.
9. Okay, here we go.
8/4.
Too late. Ha 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 ha. Thank God I got somebody snuck in there before my smart asses answer. All right. So if x is 9, and again, it could have been anything, right? That's why I like you to pick. So I'm not like picking some special number. It could have been anything. Now 9 is a little bit gross, but we're going to make it. If x is 9, what is this? This would be 9 squared is 81. 7 times 9 is 63 plus 12. Is everybody with me? So if x is 9, I just plug it in there and I see what number it actually is. So what number is this? 144, 156? Okay. Somebody double check. You never know. It's early. Now, if x is 9, what is this in this? If x is 9, what's this?
13.
13. And if x is 9, what's this?
12.
12. And what is 13 times 12?
156.
So one way to factor 156 is 13 times 12. Is everybody with me? That's the concrete. Let's pick another value of x. Let's pick another value of x. I really want you guys to get this point. Let's pick another value. Has everybody got that piece? I'm going to erase this here. All right, so can somebody pick a nice number for x? It doesn't have to be too small or something, but something better than 7/11. It would work with fractions too. It would just be, you might understand it to be a little bit worse, but maybe I'll take a turn. Let's say -2. If x is -2, then what's this piece? This would be 4, right? -2 squared is 4. 7 times -2 is -14 plus 12. So this would be -10 plus 12. This is 2. And if x is -2, this would be 2. And this would be 1. 2 times 1 is 2. Ooh, good pick, Jeff. So I really want you to get this. When we do this problem, and we do all this here, right? And we get this solution, we have just factored an infinite number of numbers. Because x could be anything. Do you understand? So when you think of it that way, that was damn easy for doing an infinite amount of work. It's like, holy shit, that was a relatively easy job. All right, let's see, what time is it? Okay, let's do one more and then we'll call it a day. So I'm going to clear all this away. All right, here it goes. It's going away. Everybody ready? Bye. Okay. So one more problem. Here we go. X squared. What do you got, Jeff? Oh yeah, let's do a negative something. Yeah, -4 minus 4x minus. Yeah, let's do something really nice and gross. All right, it's not too gross. So let me ask you guys. I need so real quick. We know this much. What do I put here and here, of course?
X.
X and X, I like it. And of course that makes x squared. All right, whoop-de-doo. And then I need to figure out what the numbers are. That's the problem. The numbers are the problem. I don't know if it's plus something, minus something. What do I know is true about the two numbers that go here and here? Two numbers that do what?
Multiply to be 60.
Multiply to be -60. Holy macaroni. Can I freaking get that out? Multiply to be -60, and they have to add to be what?
-4.
-4. I like it. Don't say anything. Don't type anything. Try to figure out what those two numbers are. So normally when people realize, a decent number of people kind of like this type of puzzle. You might not be one of them, but a decent number of people kind of like this kind of puzzle because you can kind of come up with your own way to do it. You can sink your teeth into it. You can guess some things. I don't know. So the standard way they teach this is to start with the multiplication number and start breaking it up. Right, so this is like 2 and 30, but that ain't never going to add to be 4 of any kind, right? Do you guys see that? It could add to be 28 or negative 28. Does everybody understand the thought process? And then you can say, okay, well, it's 4 times 15. Well, that ain't going to make 4. Ah, get out of here. 6 times 10. Can that make negative 4 when you add them? Now, again, remember, they multiply by negative, so one of them has to be negative, right? If I make the 6 negative, 10 minus 6 is 4. So, of course, I need to make, I'm sorry, I cut somebody off. I need to make the 10 negative, right? Doesn't 6 minus 10 equal negative 4? Do you guys see the idea? I need two numbers that multiply to this and add to be this. So one way to do it is to make a list of numbers that accomplish the first thing. And then check to see if they accomplish the second thing. Nope, nope, yes. And then what do? Then you're done. Plus 6 minus 10, done. And how do you check your work? Just multiply the damn thing out and make sure you get where you started. Oh. Okay, somebody likes it. I like that. Thank you. Oh, you sent it to everybody, so everybody can see Sam likes it.
Yeah, but you gotta say it your way, Jeff. I like it. Yeah.
I like it. Maybe. All right. So people hate this. And that's because, I don't know, that's several reasons why. But once you tunnel down, like this step here, these x's, as long as this is 1x squared, it's always going to be freaking x and x. The whole problem boils down to what are these numbers? And that boils down to a beautiful like number puzzle, which I know you wouldn't do if you're sitting around bored doing go, let me do a number puzzle. But relative to some of the shit we've done, that's not that difficult. All right, so we're going to get a little deeper into this tomorrow. For now, I think that's enough. Let me know if you need to hang out and ask questions afterwards. Otherwise, you are free to go. And remember, we're off Wednesday, right? I give you guys Wednesday off also because I give myself Wednesday off too. Haha. Anybody?
Okay,
Yes.
it's a homework question.
Sure.
Page 532. So right there, number 3. Did you want me just to graph that, or like the I think we worked on how to find the more precise way to do it, right? Rather than just graphing it.
Yeah, I forgot this is in here. I should not have assigned number 3 because I can't assume everybody's got the right calculator or Excel program. And I didn't show you how to do the line of best fit for that. And I don't intend for you to do this one by hand either, although that would work. You could figure out the slope roughly, and you could figure out from any 2 points, right? But so if you want to try it, you can. Otherwise, I can tell you just to throw number 3 out because it's asking you stuff that we didn't. I'm not going to assume people have access to.
Okay. All right. Cool. Thank you.
Sure.
I have a question.
Yes.
On page 499, question 1. So when the equation I have is 2 to this little, what is it called? Square root.
Yeah.
Is it the square root? Okay.
Yeah.
So 3 minus 0.67 divided by 90. Does that look right?
So, say it one more time.
2 to the square root of 0.33 minus 0.67 divided by.
Oh, I see. There's no minus in there. This is times.
Oh, that's what I'm doing wrong. Okay, because I was like,
Yes.
got it. Nice. Okay. Well, then you answered my question. Thank
Yeah,
you.
is that homework that I graded? Because I remember circling that in somebody's homework, the little minus sign.
Not mine. I haven't handed in.
Okay, gotcha. So somebody else is doing that same thing. And I think it's because the formula they use is p hat times 1 minus p hat. But we know that this is q hat. But it's still times. It's still times, yeah. Okay,
Okay. Awesome. Thank you so much.
you're welcome. Everybody else all right? What's up? Is everybody all right? What's going on? All right, I'm gonna head out, guys. If nobody has a question, I'll see you guys later.